In previous lessons, we've discussed how we can find some information on our types, some data on our types. For example, we can find the size of our types using size of, or we can find the limits of a type using predefined macros or numeric limits. Now in this lecture, we want to discuss how we can find the ID for a particular type, so what a particular type is, and of course this is useful if you have a complicated type, or you have some pointer, for example, and you want to get what that pointer is actually pointing at. Now the type ID operator is used to check the type of an expression. The operator returns a reference to the type info, and I mentioned this because the operators is equal to and not equal to are overloaded to work with that type info type. And this is useful if you want to perform a check on two types. So if you perform an if check, you have two of these type ID operators, and you pass in integers x and y, and you can check then if those are equal types. Just as an example, we will see an example of this in the lecture. Now we can also use the name member function to return a C string that will represent the data type or class name. Now that is useful if you want to actually print out the name of a particular type. But as I mentioned, we can also do comparisons with the type ID operator. And to use, we will include the file type info, because that is where the type info type is declared. Alright, so in this lecture we have some class entity, so a user-defined type, and then we have some predefined fundamental types, so we have integer, for example. Now we have seen this in the lesson on pointers and references. This can be confusing because what we have here is actually an int y, okay, but x is a pointer to a type of int. Then I simply have this entity instantiation as well. Then I have a constant pointer to an entity constant, and then I also have a constant pointer to an entity for pointer 1 and pointer 2. Then I print out those types. So for x and y, we find the type ID. We use type ID, we pass in the particular type in the parentheses, and then we do the name method, alright, the name member function for both x and y. Then for entity, we do the same thing, type ID, we pass in the entity here, dot name, and then you can also pass in, for the pointers, we pass in the pointers here. So we do pointer 1, pointer 2 dot name. Build and run. So we get types, we get pointer to int. Right now that is a pointer 64 because we build this program, this particular program, I'm building in x64 instead of x32. Y is going to be an int. Okay, so we've discussed this in the lecture on, I'll just minimize this here. We've discussed this in the pointers and references lecture. Y is actually going to be an integer, it's not going to be a pointer. Only x here is going to be a pointer. And that is what we can see with our type ID. Entity is going to be a class entity. And then here is the syntax, what we get for those pointers. We get pointer const, and this one is actually going to be pointer class entity, so it doesn't show us const here. Now I would like to note that different compilers will put this out in a different way. So for an int you may actually only see I in some instances, but with the Microsoft compiler we get int actually displayed. So you can also do this with a literal, so I'll just pass in a literal for the type ID dot name. And of course 47 is going to be an int, so we get the 47 literal printed out and then followed by int. You can put in a space if you want, of course. Finally, let's add one more pointer. Alright, so this pointer, I'll actually remove const here. So we have a pointer, so pointer 3, and then we have that entity on the heap. We want to allocate to that heap object as well, so I'll delete ptr3 here. Then we want to print out whatever the pointer 3 is actually pointing at. So not pointer 3 the type, but what it is pointing at. So we have to dereference pointer 3, okay? So where we have the type ID, we actually want to dereference pointer 3. If we only pass in pointer 3, as we've seen with the previous pointers, we get the type of the pointer, but we want to get the type of the heap object entity. So let's build and run. As you can see, pointer 3 is pointing to a class entity on the heap. Right, so those are some basic examples from the fundamental types and then also user-defined types. So we have pointers and then also how we can find the type ID of a pointer and then also what a pointer is actually pointing at. Of course, this is very handy if you have pointers and you are working with static or dynamic inheritance hierarchies and you want to find what a pointer is actually pointing at. Alright, so let's move on to a couple more examples. I would like to note that we will include the type info file when we use the typeid operator, and that is because the typeid returns a type of type info. So up until this point I actually did not include that file, but in some cases with some compilers you may get an error. With the Microsoft compiler it may work fine, but in some instances, as I mentioned, with some compilers you may get an error. I will remove the previous code here. I will leave the first declarations, x a pointer to int and y an integer. Now, as I mentioned, we can actually do some checks. We can do an if statement here. We will check if type ID, and I'll pass in a literal, an integer 47 is not equal to type ID, and we can pass in a type. So we can actually pass in a type. I'll pass in integer here. To a console output cout, types are not the same. Otherwise, types are the same. And we can build a run. And in this case we get the types are the same. If I change this to a float, then of course if we build a run, the types are not the same. So we have to change that to a float then if we want those types to be the same again. So again, typeid is going to check the type and is going to return a type called typeinfo. And we can compare those using the is equal to or is not equal to operators because those are overloaded to work with that typeinfo type. I will comment this out here, this if check. Actually copy that and paste that down here. Now we have those variables x and y, so we can do a type ID check of those, do a comparison on those. Pass in x for the first one and y for the second one. And actually I'll just do a few more cout statements, printing out what x and y is. But of course for this we use type ID x and then we use the name member function. And as you can see here, that is going to return a C string. I'll also print out y, so typeid y dot name. Copy those lines and paste them down here. Build and run, and those are not the same. X is a pointer to an integer and y is just an integer, right? So just a couple more examples. With this example we can see that if we do a comparison with typeid using the is equal to and not equal to operators, those are overloaded to work with the typeid. If you use it and you pass something in, that's going to return something called typeinfo, the type of typeinfo, and those operators are overloaded to work with those. And as we've seen, we can use the member function name on the typeid to return a C string, which we can then print out. For this next example, we have a polymorphic inheritance hierarchy, so we are going to use virtual functions. We have a base class and then a derived class, which is going to publicly derive from base. Okay, we have a virtual destructor here and some virtual function. In this case, I'll just use toString, even though we're not actually going to use this here. So again, we have base and derived. Then I go and allocate on the heap a new base and a new derived object. Both of those will be assigned to a pointer to a base. Alright, pointer to base 1 and pointer to base 2. So again, pointer to base 2 is pointer to base, but the type on the heap is derived, right? Then I go and print these statements out. Pointer to base 1 and 2 is, and then I use typeid and the name method. And I'm just going to pass in the pointer here. So of course with this, we are going to get the static pointer type. So this should print out pointer to base. Then here what I'll do is I'll dereference those. Alright. Pointer to base 1, again that is pointing to an object of type base on the heap. Pointer to base 2 is going to point to a type of derived on the heap. Next, I also want to demonstrate that we can do the same sort of thing with references. So here we have a derived instance. I instantiate derived. Then I have a reference to a type of base here, rbase, and I assign that derived to that. So rbase is basically an alias for that derived object now. Then we go and do this statement, derived, and I pass in typeid derived.name and then rbase typeid rbase.name. Finally, I'll deallocate those objects on the heap. Let's build and run to see what we get. Firstly, I mentioned that we print out pbase.name. So using typeid, we pass in pbase and then using the name member function. So we get pointer to base. Okay, so pointer to a base class. It also actually shows us what type of pointer that is. It's a pointer 64. If we dereference that, we actually get the base class for the first pointer, and then we get the derived class when we dereference the second pointer to base. So it's going to give us, or in other words, yield the dynamic type. Or in other words, if these were not polymorphic types, you would not get these results, then you would get pointer to base here again. So then derived, we are using those references down here. We are printing out derived and then rbase. So with that, we get the class derived and then class derived again. Even though the reference here is a reference to type base, we get derived printed out. So just to demonstrate, if I go and remove these virtual keywords here, with the destructors and with the toString functions, and if we build and run now, notice that we get class base each time, apart from here where we have the actual object with derived, but in the other cases we get base. Alright, so that is going to wrap up this demonstration on the typeid. Quite a few useful things that you can do here to compare types.